Hey everyone, my name is Rahul Patel,
My name's Hara Wang.
And I'm Jacob Luthold.
and today we are gonna demo how to fuzz Rust with AFL. Our motivation for this project was to learn a testing strategy that can be used to find bugs for unusual state of a system. In particular, fuzzing allows us to check the robustness of a program. Due to the certain circumstances, we had to change our plan. Originally, we planned to conduct this demo by finishing Lab 3 by implementing a file system in Rust. Once we had implemented the file system, we planned to use an existing fuzzer to test our file system. This would involve mutating the disk image. In particular, we would mutate the meta blocks of the file system, such as in an eBPB block. Once we've mutated the disk image, we would execute the file system commands, such as open, ls, and cd, and check if those commands work and show the correct output. But we ran into a certain issue. We were not able to finish lab 3. So our new plan is to fuzz a compatible Rust code and show the result of the running fuzzer. We chose to use the American Fuzzy Lob for our demo. In particular, we will be using afl.rs. To install the AFL, you can execute the command cargo install AFL in Linux. To fuzz efficiently, it is important to provide good input. By providing good input, the fuzzer spends less time on guessing what the pattern is or the type of input a program accepts. If we provide the correct input, it will then focus on just mutating the certain variables rather than varying the size and guessing the pattern. To run the fuzzer, we can use the fuzz macro to call the AFL library code in our fuzzing code. This will give us access to the mutated data that the fuzzer has mutated in library, which we then can pass into our program. To build a program, you can execute the AFL build utility of the cargo file. Once it is built, a binary will be stored in the folder named target. We will use this binary to then run our fuzzer on it. Finally, we will run the cargo fuzz command to run our fuzzer. We will point the input to the input we created previously by providing the correct input. And then once we're done running the fuzzer, we will see our output, all the paths, hangs, and crashes that might have occurred in the folder specified by the -o. Next, we will talk about the other fuzzers that we could have potentially used. These three are just some of them. But for this demo, we will be using afl.rs. Next will be the demo.
So I'm going to demo how to fuzz a file system like that we made in Lab 3. So this is our project look like. We put our file system here in RustOS, and this is different fuzzers we made. To fuzz our file system, we want to use the VFAT fuzz. And then to create, the first step is to create test cases for fuzzing. To fuzz file system, we want to use different type of disk images. So to create a disk image, we first create a file filled with random characters. This command line takes random input and then output to test.image. So it produces a disk image of 100 kilobyte, and then we want to partition the disk image we make. So this is command we use to partition the disk image. We use N to select a partition type. For this example, we just create a primary partition, and we then specify the partition number. So in this case, it's one partition. It's from 750 to 1500, and then we change the partition type from Linux to 533, and then that's it for one test case. After that, we want to copy the test case to our input folder, which is the N folder. That's all the test cases we have. Before running the fuzzer, we have to first remove the out folder. That's for the output of the fuzzer. And then we run build. To build the fuzzer, this command gives us the target folder for the fuzzer, and then to fuzz, we run this command. It takes input from in folder and output to out folder in the target folder. Call vfat fuzz, and this starts the fuzzer. And this live screen just show us the fuzzing status. It tells us how many crashes we have, how many hands we have. Although we're not able to get a crash for our Lab 3 file system, Jacob was able to create a small Rust program that gives us a crash. But that's it.
So here we have a simple test program that demonstrates a pretty obvious crash. This would be an out-of-bounds exception. So we have, if you're given some sort of slice of length 3, and you try to check what's in the 4th position, so at index 3, obviously there's going to be a crash. So when you run the fuzzer, you get all of this output, and specifically, you will get this line here. So panicked, index out of bounds. So this tells you, what the specific issue is when you ran the fuzzer. So the reason we chose, to demo an index out of bounds, as it turns out, that's one of the most common types of errors that's discovered with Rust. So this is the Rust trophy case showcasing all of the errors that have been found using different fuzzers. Index out of bounds is one of the more common ones. Memory safety as a guarantee of Rust is typically uncommon to find with a fuzzer. So that was one of the issues we ran into, was trying to detect memory issues. But that's our demo. So thank you for watching.